Hi. Today's video, I think it's going to be one of the least duration videos in the series because it only contains one section, which is the evaluation. I actually skipped the section of implementation because it doesn't talk about so much important things, but the most important thing to talk about in this paper, not the most important thing, the second most important thing about after Atlas section, it was in the last video, is the evaluation because it talks about the numbers that shows an analysis of each component of the model proposed and the solution, and also it shows the data set that the model was trained on and how it is gathered, so it gives you an intuition of how the attacks are gathered and how do they train the model, how do they teach him or it, of course. So let's get started without wasting any time. First things first, the data set. So to conclude the whole section, it talks about that there is no data set that are available. Data set of what? Data set of attacks and their audit logs so that they can map these audit logs into the causal graph they create and then offer the cyber analyst a total analysis using the causal graph of the attack. So they collected their own dataset, and the dataset description is easy. It consists of 10 different attacks, 6 attacks of the category of multiple hosts, and 4 attacks in the category of a single host. So it comes from single host. And multiple hosts, you know the difference is such easy. The data leaked from your device, from your machine, is going to be separated into multiple hosts, and this is an abbreviation from M1 to M6. And for the single host, it's only leaked to one host, and it's abbreviation from S1 to S4. So this is the data set. So how did they collect them? By just throwing an attack on a system, Windows 7, I think, on a laptop machine, and they gathered the audit logs after throwing this attack in a controlled environment so that they can measure the audit logs, they can follow the causal graph audit logs, and they can measure whether the results are meaningful or not. And here is a second part that I want to mention in this section is that they used in training and evaluating something like cross validation. For instance, if they are training the model on the multiple host attacks, so they give the model five different attacks data audit logs, and they evaluate with the number six host attack. For instance, from M1 to M5, they are going to feed into the model to train on. And for M6, which is the attack number 6 for multiple host category, they evaluate their model with it. And this process is repeated 6 times for multiple hosts, and you can guess for the single host it is repeated 4 times. So they have 10 different models to train on. For instance, for single host, they give the model any three single host attacks data, and they evaluate with the fourth one. So how do they evaluate or they evaluate the model? Simply by just generating a symptom attack randomly from the given the data they have, and they follow its sequences, and then they compare these sequences to the sequences of the attack memorized audit logs by the model of the previous 3 single attacks, for instance. And after comparing if this attack matches with any pattern in the patterns that the model can memorize, so it is considered an attack. If not, so it's not attack because it doesn't match any attack sequences. So that's easy actually. So for the investigation, so here is an example and the difference between the attack and an attack sequence, because This is a key difference in the behavior that the model learn. For example, many attacks that open malicious web page exploits a vulnerable browser and drop and execute backdoors and extract data of interest. Okay, this is an attack. This is a real example of an attack. But normal program executions it rarely perform such activities. Rarely perform activities like executing backdoors and exploiting vulnerable browsers. So here is how the model differentiates between attack and non-attack sequences. Also, the author talked here about the analysis of false positives, which are the number of non-attack or normal entities that are considered an attack or classified an attack. So they are a very small number of false positives, but there is a problem with IP addresses. So Atlas does not work properly with IP addresses, but this is not a big deal because however, the security investigator can easily identify the IP addresses by what? By checking their traffic content. So it's going to be solved issue. Also, in speaking of the analysis of false negatives, which are the most important part of the goal of the atlas, which is the entities that are actually an attack, but they are not considered attack. They are not classified attack. So now I have an attack, and the cyber analysts do not see that attack labeled in the causal graph, in the given causal graph. So this is such a huge problem because it could eventually lead to data leakage. So but actually, one important thing that Atlas do, although Atlas miss some certain only 0.1% of the attacks it classifies them as non-attacks. At the same time, they can catch or get the attack entities resulted from the attack entity that is not labeled correctly. So eventually, if I have 100 attack entities and the Atlas missed one attack entity, which is the percentage of false negatives, eventually the cyber analyst, is going to relate this entity to the other entities that resulted from it. So this is how this problem was solved. And yeah, so this is all for this section. And for the section 6.2, let's talk in depth about how the component of optimization helped a lot in reducing the number of entities and edges. Here's an example of each attack that is created by the author, and the difference between the tall columns represents the number of entities before optimization, and the short columns they are after optimization, and the percentage shows how much entities are reduced and are got rid of. As you know before, in the last couple of videos, they are reduced by undersampling and oversampling. So if I have 20 non-attack entities, they are going to be decreased into 1000, for instance. Let's talk about numbers. Atlas oversamples the attack sequences with an average 37 factor increase from 61, for instance, to 2000, and undersamples by 9 factor, and this is from 20,000 entities to the same number of non-attack entities or attack entities. And this is reduced time from 3 hours to only half an hour. So numbers talk about how much the optimization was innovative and how much it was important. But let's talk about the comparison analysis, because this is important for me. How did the author compare their solution to the other existing solutions? This is done by traversing backward and forward from the attack symptom to the data leakage, back and forth, and comparing the number of graph entities and the number of nodes, graph entities, edges, counting them, and comparing between the other methods. How many graph entities did you get to the cyber analyst to analyze? And for Atlas, how many graph entities did you get for cyber analysts to analyze? And the least ones. because the least gives you the shortest path of the attack entity, and it becomes easier for the cyber analyst to do so. So this is how they benchmark, and actually the reason why they did this method is that codes are not available publicly from other approaches. So unlike Atlas, which you can get the code from the GitHub repo, so this is why they choose this methodology, which is fair as well. So it doesn't mean anything bad. And here they compare the solutions. They make sure they work properly with the other solutions, such as instead of one-hot encoding in word embedding, they use semantic word embedding because it gives semantic meaning of the processes and events. Also, they, instead of SVM, because it got them lower accuracy, they used the LSTM, which takes into consideration the sequence and the temporal time the event occurred in. Finally, in this section, they talk about the performance head. Actually, it doesn't add any performance head to the system because eventually they work offline on the audit logs that are stored in the last 24 hours, for instance. So maybe more, maybe less, but actually they do not cause overhead. And for this section, we can say 4 points about this section. Atlas could be used on any operating system because it is independent. It creates independent causal graph. So this is one note. It can be operated on Linux, Windows, etc. Also, manual data labeling is considered a limitation, but it's one-time effort. You can create your own dataset, but it's one-time effort because you are going to feed your dataset into the model, LSTM model. It's going to be trained, so it finished. Also, it cannot detect attacks that use similar sequences of normal events to hide this behavior, such as mimicry attacks. But this is a problem of other approaches as well. So, for attacks that use the same sequence of the behavior and hide its behavior, it's a problem with Atlas, but it's a problem with other approaches. And this is what I like about the author, because he tries to show you that, okay, this approach has problems, but eventually these problems are not major, they are minor. Either the problems the Atlas have are in the same other approaches, or they could be overcome easily. And we saw this when we talked about the analysis of false positives and false negatives, and the problem of IP addresses that you can analyze yourself manually, and the problem with false negatives that you can overcome easily as well. So back to the limitations and final sections. The correctness of the sequence-based model highly depends on the quality of the collected training log entries. So you have to take care about your dataset that you feed to the model, and it has to be something to rely on. This is for the limitations and discussions. And here is an open question by me: can Atlas framework be extended to investigate attacks in cloud environments, where the audit logs are distributed across multiple hosts and services? So this is one question that I opened. If you have any answer for this, or you have any guess, just inform me in the comment section. And thank you so much for this, for your patience and waiting until the third part. And see you in any other videos. And Happy New Year, actually, because it is 30 December. And have a nice day. Bye.